Hi, my name is Jason, and today I will be going over basic counting principle. This principle is a cornerstone in understanding how to calculate the total number of outcomes in a multi-stage decision-making process. It's a crucial tool in probability, permutation, and much more, so let's get started. All right, let's unpack the basic counting principle. Imagine a scenario with r stages, and at each stage I, there are n sub I choices. The magic happens when we multiply these choices together. The total number of outcomes is given by n sub 1 times n sub 2 times times n sub r. This principle is like a roadmap for systematically exploring possibilities in complex decision trees or scenarios with multiple stages. Now, let's put this into practice with an example. Consider creating license plates with 3 letters and 4 digits. If each letter has 26 choices, A to Z, and each digit has 10 choices, 0 to 9, the total possibilities would be 26 times 26 times 26 times 10 times 10 times 10 times 10. However, if we want no repetition, the choices would be 26 times 25 times 24 times 10 times 9 times 8 times 7. This illustrates the basic counting principle in action, showcasing the versatility of the basic counting principle. Moving on to permutations, a concept closely related to the basic counting principle. Permutation represents all possible ways of arranging n elements. The formula for the number of permutation is n factorial, which is the product of all possible integers up to n. It's a powerful tool when order matters. Let's dive deeper with an example. Take the permutations of the letter A, B, and C. There are 3 factorial, or 6 different ways to arrange these letters. This illustrates the concept of permutations. The multitude of arrangements possible when order is a significant factor. Now, let's shift gears to subsets. If you have a set of n elements, the total number of subsets is 2 to the n. Why? Each element can be either included or excluded, providing 2 options. If we want to find subsets that include or exclude a specific element like n, it becomes 2 to the n minus 1. To further grasp the concept of subsets, let's examine all the subsets of the set 1, 2, 3. It is an insightful exercise that reveals that there are 2 to the 3 or 8 subsets. Understanding subsets is essential as it forms the foundation for more advanced concepts in probability and decision-making scenarios. Now, let's tie all together with probability. Suppose we are rolling a fair 6-sided dice 6 times, aiming for different numbers each time. The probability is the number of favorable outcomes, 6 factorial divided by the total outcomes, 6 to the 6. For a specific sequence like 2, 3, 3, 1, 6, 5, the probability is calculated by multiplying the individual probabilities of each roll, resulting in 1 divided by 6 to the 6. This illustrates how permutation and the basic counting principle play a role in probability calculations. Understanding the basic counting principle, permutation, subsets, and their applications in probability equips you with a versatile set of tools for tackling various real-world scenarios. I hope this breakdown clarifies these concepts for you. Thank you for watching, and in the next section, Darren will be going over combinations.